G'day viewers, Alan here, welcome to my workshop. So I found some time to do a bit more work on the Webster engine, and as you'll see in this video I've managed to sort out the fuel tank, get the exhaust valve timing sorted and pin the flywheel, and made a driver so I can spin the engine over with a power drill when I want to go and start it. So all good stuff, let's dive in and see how it all happened. So at this point the flywheel is still free to rotate on the crankshaft, so we have to pin it to the crankshaft using 532's roll pins, pretty tiny little fellas. And when the flywheel is pinned to the crankshaft, it sets the exhaust valve timing. So the instructions for it are to set the crankshaft at 15 degrees before top dead centre and with the exhaust valve just about to open. So to get the crankshaft set at 15 degrees before top dead centre, the easiest thing is to locate the pin in a block with a hole drilled at the correct height. Now in my case I've got the centre line of the crankshaft 50mm above the surface here, not 2 inches, so I needed to recalculate that. It's pretty simple. We know what the centre to centre distance is, we know the 15 degrees, know the sine relationship, so we can easily work out the vertical offset there, add to 50 and off we go. So that in my case needs to be 54.11. I'll just slip that on. And the other part of the deal, I'll turn this whole thing around in a tick. The other part of the deal is to get the exhaust valve just about to open. But I'll have these couple of bits of scrap in here. Let's pull that back a little bit. And it's a reamed hole, so it's a pretty good fit. Right, I think that'll be enough. Yeah, so I better put that in there and put a decent sort of a clamp on there, across there, and that'll stop the flywheel from rotating. So anyway, we'll turn him around and get the exhaust valve in the correct position. So I've got the crankshaft locked at 15 degrees before bottom dead centre, and I have a 10,000 or 12 thousandths of an inch gap under the end of the valve stem between the tappet. You probably can't quite see that, but when I turn the flywheel you'll see that gap close first and then the valves start to go. Just there. And I'm going to call that the right position, so I'll clamp it off at that point. Alright, so I'm all clamped up. I've got the bracket clamped to the plate with a toolmaker clamp, and then another clamp across the flywheel and the bracket to hold that all still. So just to repeat, the roll pins that I have to use, I might have called it out incorrectly before. These are 332s, or nearly 2.5 millimeters. Now this is a 332 drill, but I did a test hole with it and it was tight as hell for these, so I'm not quite sure how this is going to work out yet. I'll put this drill through, but I might have to open it out to 2.5. The other thing is that just trying to get centered here on the gap between the gear down there and the face of the flywheel, and then also centered on the center line of the crankshaft, I wasn't able to use my the center finder I usually use, and I used this one. I haven't used this one before, but it actually worked out quite well. And you can see it has a very small radius or diameter follower on the end here, and I was able to feed that down into the gap there and get centered on the that flywheel boss in both directions. So I think we're good to go. Right, so I think the ticket's going to be high speed and very ginger feeding, and let's hope for the best. No, I didn't like that. The drill immediately bounced off the curved surface, so I have to think what I can do about that. Okay, so I swapped my right size drill out for the biggest drill that I've got that'll fit in there, which is a 4mm drill, and we'll see if we can use that to create a divot to start from. Let's try again. Right, well that I don't know whether you'll be able to see that, possibly you can. Anyway, that's made a little divot, so let's see whether that's enough to get the correct drill started in the right place. I think I better have a bit more drill hanging out the bottom. So I think we're nearly through, or at least I hope we are. There we go, one done. I won't try and film doing the other one. It's just too awkward. So this is my setup for pressing the roll pins in, punching the chuck and using the rack and pinion of the milling machine to put some press on. Pretty tight fit. There it is. It's not coming out in a hurry. So I'm making the driver bit here and I want to use this 2mm dowel pin in a cross drilling in the end of this bit. Which is the bit which will float around in there. Right, so to try to get a press fit for this 2mm pin in this shaft, I'm using, I think it's a 5/64 drill. Yes, 5/64, which is a couple of thou undersized, so we'll see how that goes. I better speed this up a bit too, I think. Yeah, I don't think you better. Oh, so you can pick up in the picture. I have already put a little divot there to get the drill started in the right place. Yeah, that should work. Right, let's clean that up and see how I'm going to get on pushing the pin in. Let's hope that it will press in. Oh, that's got a nice feel to it. Yep. It's out the other side. That's really good. So all I've got to do now is make sure I get it centred. I think I'll leave it at that. I guess I can always drive it a bit more later if I see fit. Oh, that's good. Right, you saw me make the drive bit, but now I want to make a thimble that will press onto the end of the crankshaft. This is a practice piece, so I can show you the method I used. And the slots in the end there will engage anti-clockwise but kick it out going the other way. Well, that's the plan anyway. So it's an awkward little thing to machine, or at least I couldn't see a particularly easy way to do it, so this is what I've done. This is the correct piece that we're now going to make. So I've got it set in the milling machine here, and I've used the centre finder to centre this scriber on the centre line of the thimble when it's in line with the milling machine. But I actually want to mill at 30 degrees, and finding centre when it's cocked around was causing me grief. So what I'm going to do is put a centre mark right on the end here, and I'll just index off that by eye. It seemed to work out alright. If there's a better way to do it, I don't know what it is. So we'll do a scribe, we'll come down, there's nothing too precise here because I don't think it's actually that important. I'll do a 0.2mm depth of cut scribe. Doesn't have to be very long. It's really just need a mark which I can translate onto the front face where I'll be able to see it. Okay, so we've got the piece mounted in the angled vise now, and this vise is angled at 30 degrees, so that when I do a cut with the just in the x-axis, that's what will produce this angle. And it's also the reason why I needed to have a reference mark made onto this piece before I put it in the vise, because angled like that, I don't know of any easy way to find the centre of the piece. So anyway, I've got it positioned now, so the point of the scribe is over that index mark which you saw me make in the vise, and I've set the DRO X and Y to 0, 0. So now it's time to switch over to putting the milling cutter in. The milling cutter I'm using is a 2mm diameter, because that's the size of the drive pin I've got in the end of the bit. Now this is 2mm thick, so I'm going to do 2 passes with a depth of cut of 1mm each time. And what before I started this, I did some work with the CAD software and worked out, because it's just a bit hard to explain, I wanted the slot to be centred on the centre line of the thimble. And it's a bit complicated, or at least I thought it was. Anyway, so what I've got to do is start offset from the centre line 0.68. That's in the Y direction. That's so that as I cut in, half of the cut is on one side of the centre line and the other end of the cut's on the other side of the centre line. Right, and I have to move in the X direction 1.75mm. These are weird numbers, but from a trial run it seemed to produce the outcome I was looking for. So we've got to do this, run this pretty fast, 2000 RPM. And that should be one done. We'll flip him over and do the other side. Now, of course, before I do that, I have to make sure I don't lose my index position in the vise. So the last bit of this setup is a stop lock, so I can turn this over without losing the position this way. And hopefully that's it. Now I expect I'll need to do a bit of cleaning up and with burrs and things. Let's pull it out of the vise and check it out. So I've had a close look at the problem, and it wasn't a burr. The issue is the cutter path geometry wasn't correct. In an ideal world, both sides of each of these slots would be pointing at the middle of the piece, but they're not. And that's because I moved offside to do the cuts, moved off the centre line. So I finished up that the inside corner there and there was quite incorrect. It should have been inclined almost that way, but instead it was inclined the other way. Anyway, I've given it a quick go with a file, and I think you can see now that it sort of works the way I wanted it to work. So when you put it in, it turns around, and the idea, of course, is that you can turn it that way to turn the motor over to start it, but as soon as it fires and it overtakes this driver, then this will climb up the back and kick it out. And it sort of works. It doesn't work too badly, but it's not completely smooth. But nonetheless, I think it will be good enough for what I'm trying to do. Yeah. So I mean, to try to cut the slots with the correct geometry, this sleeve needs to be rotated as the cutter is pushed along the length of the piece, and that's not something I can easily do. So I might just loosen this up slightly with a bit more firework, but otherwise call it done. Interesting exercise that. Right, so that's got the electric starter organised. So that should make it easier to start when the time comes. Okay, time to move on to the fuel system. Now, I think I mentioned in the previous episode I don't want to use a carburetor because that'd be $100, and it's sort of not in keeping with the idea of building all this lot from scraps lying around. So instead I'm going to try using what's called a petrol vapour carburetor, courtesy of, I think it's Jan Ridder's. I'll have a link below to follow up on. But the idea is simple enough. The job of a carburetor is to provide atomised fuel to the engine. Well, there's another way to do that apparently. You have the Coleman fuel or petrol, whatever, in a tank, and the arrangement is to for the engine to draw it from one end of the tank, air in from the other. Air comes across the top and picks up the gas mix that's hanging around above the fuel, draws it in, and you can adjust the air fuel mixture. There's an air bleed here, quite similar to what you get on the old Bunsen burners, and you wind this thimble backwards and forwards to open and close that, and it's as simple as that. So that's what I'm going to do. So first up, I found a scrap of aluminium tube, over to the lathe, cut it to length, and then start machining a couple of end caps. So I've got to shorten this bit of stock by 20 millimeters. What's going on there? Am I off centre or something? Ah. Balled up on the tip, I think. Yeah, so aluminium was building up on the insert. I should have been using some lubricant. So I've parted it off to length and faced it, and now I want to clean out the bore for a length of 7 millimeters. I'm going for a diameter of about 36.2, although that isn't critical. That should be somewhere near 36.2. That was slightly over. Okay, so now I want to make the plugs to go in the ends of the tank. And in a first for me, I've stuck this disc which I cut out from a bar to this backing piece using super glue. But I don't trust it completely, so I've got a force pad here to which will turn with it and make sure it doesn't get up to mischief. So the first move anyway is to knock these corners off and get this thing round. Right, we're just starting to engage, so I'll start getting serious now. See how we're going? Oh yeah, making some progress, but obviously got a long way to go yet. Alright, so I've switched tools because I'm becoming interested in surface finish now, and I'm getting towards the size that I want. This will be my final chance to make any change to the setting. So we're aiming at, I was aiming for 42.5. If it isn't right, it's my fault, not yours. 42.498, and that felt a little bit tight actually as I had that on there. 42.499, well that's close enough to 42.5 for me. Right, so next cut's the last one. We're going for 42.1. So we were shooting for 42.1 and got 42.099. I'll take that. So next move is to cut a shoulder here, so I've got a piece that will fit into that, and with a rim to butt up against that. So now we're shooting for 36.23. So aiming for 36.23, and we got 36.232, so that's pretty good. But what counts is whether the cylinder will fit. Oh, you can see that's going on there. That's going to be a really snug fit. So I decided to use Loctite 648, and it's actually a lower viscosity than the 638 and more suited to tight tolerances. In fact, the maximum gap they tell you is 0.15, but reading the data sheet, it actually says that it's recommended for slip fits and also press fits. So that's what we've got here, an almost press fit. So that's what we'll be using. Alright, well I'd say that's finished this end. The rest of the cleanup can happen when it's assembled. So we've got to persuade this piece that was Loctited on there to come off now. I'm hoping that a bit of heat will be all that's required to do that. Now, I haven't tried to do this before, so I don't know exactly how much heat is required, but I'm thinking one of these TF gas things should be able to get hot enough. I'm just not sure that even when you get the temperature up, whether it takes a bit of force to get that off or it will just slide off. I guess we'll find out. Well, that took a lot more heat than I thought it was going to take. That's one done. And stay away from that, Alan, it's hot. Right, one done. And now I've finished the aluminium bits, I've moved on to doing some brass pieces, in particular the fuel vapour outlet to the intake manifold. I've already made a central piece of that fitting, and I'm now going to make a thimble which screws onto it and is used to open and close an air bleed port, which is in turn how the fuel mixture is adjusted. So I'm making the thimble to go onto this thing now, and I've just turned this 12.7 or half-inch bar to 12 millimeters. So now I need 9 millimeters of length turned down to 8. So presumably we finished up somewhere near 8. 7,996, well, that's good enough. So now I have to do some knurling on this piece back here. I don't do knurling very often. Now, I haven't done very much knurling, and I'm using the knurler that I bought for my Hercus here, so it's a bit small for this, but it's probably the right size for this job actually. Anyway, I understand the magic recipe for knurling is low RPM and lots of oil. So let's see how that works out. Not the cleanest, tidiest looking knurl. So obviously I didn't do something right. Maybe I should have come in from, fed it that way instead of in. We're a bit late to try that now. Yeah, I think we'll just take what we've got with that. Not ideal, but it'll get the job done. changed my mind, decided it wasn't good enough. So because the diameter that I was knurling is arbitrary at 12mm, I've turned it down to 11mm and got rid of the previous attempt at the knurl, and I'll have another go. This time I'll do it with the knurling in place and just turn dial the knob up without removing it, and we'll see if we get a better result. Well, that looks a bit better. Well, I've got a very clearly defined crosshatch this time, and it looks a hell of a lot better than the previous effort, so I think we'll just go with that. Okay, set up now to drill and tap for M5. Righto, for tapping for M5. I like tapping in brass, it's so easy. You don't have to worry about straggly swarf building up in there, spoiling the game. So that was the taper tap. So we go in now with the bottoming tap. So a little bit of a chamfer and a parting off, and we'll be done. So now, of course, this has got a hole all the way through, and it's air bleed screw, so I need to mill a slot here now, which can be covered up or uncovered as necessary to change the air fuel mixture. So that should do that quite nicely. Okay, so to follow up with the lousy camera work in the previous scene, I decided to leave the microphone off apparently. Anyway, what I'm carrying on about here is that I need to create a slot 7mm long in this shaft and 2mm wide. Now I don't have a 2mm slot drill which I could use to plunge straight in, so I needed to create a pilot hole which I could then use as the start point for an ordinary 2mm end mill to side mill with. And anyway, I used, I believe, a 5/64 drill to be just slightly under 2mm. So I was a little bit ginger about this because I didn't want the drill to spear off to one side or the other. Yeah, because these drills this size just look for any opportunity to go sideways. Well, that's been my experience anyway. But on this occasion I didn't have a problem, and I was able to plunge the drill right in and get the pilot hole that I needed. So with the pilot hole done, it was feed the 2mm end mill in, and because these things are, in my experience, or at least in my clumsy hands, so fragile, I did 2 passes at about a 0.5mm deep each, and that seemed to work out alright. And I was able to successfully create the slot without breaking the end mill or wandering off course, so happy about that. Okay, so it's starting to come together now. So that's my fuel cylinder for my fuel tank, and one of the 2 end caps. I've already got the other one mounted there, and these are the fittings I've made. The fuel mixture outlet with the air bleed adjuster, and this is a spigot for the drain out the bottom of the tank. So as you can see, there's quite a step in from the outer diameter, so I have to allow for that when I drill the hole. So what I'm doing at the moment is 1 hole at the top and 1 at the bottom on that end to create the outlet and the drain. So start off of course by centering on that. So I've got that pretty well sorted. So now I can start, and I've zeroed the DRO, X and Y, so now I can get positioned to drill the holes. So we're on target now to drill a 5mm hole to be tapped M6 for this guy. Okay, I come forwards and do the other hole. So we finished this little fellow by hand, so I've got a bit more feel for what's happening. Particularly when I'm removing the tap. It's very easy with this sort of leverage and horsepower to just pull it out the last few turns. So to make a washer to fit on the top of the tank and match the profile of the tank, I turned up a bit of 16mm aluminium and used the boring head to put the profile on that I needed. So I actually started with the 1.5 inch hole saw which I bought recently, the what do you call it, the annular cutter. Anyway, I've now opened this out a little bit because that cutter's 38 and the diameter of this is 42. So I've got the diameter of this up to 40 now, and it's already looking like a pretty good fit. I think we'll go another. I've been taking 0.5mm increases in diameter, so I'll do another one. So 5 full rotations of this advances it 0.5mm, and we'll keep going till I get the fit that I'm looking for. Okay, well, let's see if we can stick one of these ends in. Let's see how we go. They tell you when you're putting the press fit with this stuff not to dick around. Oh, there we go. It's together. See if we can get some of that excess off. I think acetone's the go. We'll give that a try first. Yep, seems to work just fine. A bit more, second clean up. Oh, there we go. That seemed to work out alright. That's one end on. Hard to hold that right in the right position, but that worked out pretty well. So here I'm getting set up to drill the hole in the top of the tank for the fill plug and the air intake tube, and what I've done is knock up a bit of scrap and put a hole pattern in, a bit of scrap that matches the hole pattern in the end cap here, and I was careful to keep it all lined up. So now I can put a square here, and I know that how can I say this? A horizontal tangent to the top of the tank would hit the centre line of these two, if that makes sense. Anyway, bottom line is I'm thinking that with this setup I can drill a hole in the top of the tank in what will look like the middle. So we go around the other side and have a look, because that's where all the action is going to happen. So I think you can see what's going on now. So this is for the fill plug. So I'll do a starter hole, and then I'll be opening that out and tapping it for M10. This material is 3mm thick, so it's a bit marginal whether it will hold an M3 thread, but all it's got to do is hold that cap, and it'll never be done up tight, and it gets done up finger tight against an O-ring. And I think in my lifetime it's not going to be a problem. If it is, I'll worry about it when it shows up. Yeah, I didn't want to stress the thread on that withdrawal. there's not a lot of that thread, and it's in aluminium, so needs to be looked after. Local train registering its displeasure at something. Alright, let's get this out and have a look. Alright, well that seems to have worked out alright. I don't know how well you can see, but they are in a line, which is what I was shooting for. I didn't show you much detail of me making this screw, but there's my threaded hole, and that's the breather thing. The needling worked out a bit better on this one. Now, what I'm going to do, my plan anyway, is to super glue this shaped piece to the top of the tank. No idea how well that will work, but it's not critical. It's above the fuel line and it's open to atmosphere anyway, so probably doesn't even need the super glue, to be honest, but anyway, that's the plan. So it's looking pretty good, and with that done and the rubbish cleaned out from the inside, I can put the other end on. Okay, as you can see, I've finished assembling the tank and I want to leak test it now. It won't actually hold pressure in operation because it'll be vented to atmosphere. But putting a bit of pressure in is the easiest way to actually test it. So a bit of a lash up, Schrader valve here, blocked off what will be the vapour outlet with a bolt with an O-ring under it, and that's the drain line with a cap on it. Now I've got my workshop air pressure turned down to about 15 psi at the moment, so we'll put that sort of pressure into the tank and just make sure that was what we were getting. Yeah, so we're just around 15. It's a nominal pressure, just enough to prove that it's leaking or it isn't. And we drop that in the water. And just because I can, I'll let the pressure out underwater so you can see I wasn't messing about. There we go. Very happy. So with the fuel tank made and tested, the list of outstanding things to do is getting quite a bit shorter. The fuel tank isn't fixed yet, that's one of the items. And I haven't got the hose yet sorted to go from there around to the intake side, so I have to make a little tube to go in there and then the hose to connect them. It's not a big deal, it's all stuff to do. I've made quite a bit of progress since the last video, and I can show you a couple of things that are interesting. I guess for me the most interesting or exciting development was that since I've pinned the flywheel, I can now actually rotate, and I've got it all pretty much assembled now. I can actually rotate and hear it chuff. I don't know whether you'll be able to hear that. I've got a dummy spark plug in. This is just a plug I machined up, and there's a fibre washer under that just so this can build compression. But this is interesting to see as well when it's coming up on the compression stroke. Now, actually I'll turn it around, you'll be able to see that it actually bounces on the compression. I think that's showing that I must have the piston ring bore clearance and all that pretty much sorted, because there's enough restriction to build pressure, but it doesn't seem to cause too much resistance to travel. So I'm a bit optimistic that I've got that right. Now what is an issue though at this stage, if I just put a little bit of CRC there, you'll see it happily blowing bubbles there. So I'm going to have to make some gaskets, a gasket set probably. That's another item on the to-do list. But I'll turn it around so you can see the other side. You may be able to see I actually have grease in here now, so this connection is being lubricated. But I think you'll be able to see that it's bouncing off the compression in the cylinder, which is a good thing. So happy with all that. It's all good progress. Actually, I should have, before I turned it around, could have demonstrated the electric start. You can hear the motor in the drill picking up the load when compression comes on. So, all good progress. Well, perhaps you'll agree that's a useful bit of progress. Fuel tank, crankshaft, compression. Yeah, so the to-do list has got quite a bit shorter. I have to do the fuel line from here to the intake car side, mount the fuel tank, it's just sitting there, sort out how to mount the coil and connect it, and I think that's about it. Be into first start territory and see what happens. Oh, sorry, I've got to set the ignition timing too. I don't think that's much of an issue, but it's something I haven't done. Anyway, so I think the next episode will be make or break. Hope you'll join me. Cheers.